Hi everyone, I am Maheswari, Assistant Professor of Mathematics, St.Joseph College for Women, Tirupur.
Now we are going to see about discrete mathematics. Connectivities to construct a complicated statement from simplex statement by using certain connecting words or expressions is known as connectivities. Now we want to create a complicated statement from a simple statement with using a connecting words which is known as connectivities. Now we are going to see about the types of connectivities. The first one is negation, the second one is conjunction, the third one is disjunction, fourth one is conditional, fifth one is biconditional. Negation. The negation of the statement is generally formed by the word not. The negation of P is written as negation P. The truth table for negation P and negation P. The first column is P, the second column is negation P. True, it will come false, false, it will come true. Example, the statement P is London is a city and negation P is London is not a city because the negation is formed by the word not, that is we are used. Conjunction. If P and Q are the statement, then the conjunction of P and Q is P conjunction Q, which is read as P and Q. The statement P and Q has a truth value T whenever both P and Q have the truth value T. Otherwise, it has the truth value F. The truth table for conjunction. The first column is P, the second column is Q, third column is P and Q. By the definition of conjunction, the third point is the both P and Q have the same truth value T means we have T, otherwise it will have false. Example of conjunction. The statement P, it is raining today. The statement Q, there are 20 tables in the room. The statement P and Q, it is raining today and there are 20 tables in the room because the conjunction is formed by the word and. The right side of the panel is conjunction set. The first one is A, the second one is B. The center portion is A intersection B. That is, the center portion is also in A and also in B. If P and Q are the statement, then the disjunction of P and Q is P disjunction Q, which is read as P or Q. The statement P or Q has the truth value false, only both P and Q have the truth value false. Otherwise, it has the truth value T. The truth table for disjunction. The first statement is P, the second statement is Q, the third statement is P or Q. By the definitions of disjunction, the third point is when both P and Q have the truth value false means it will come false. Otherwise, we have the truth value true. Example of disjunction. The statement P is Anand go to school and the statement Q is Anand go to office. The statement P or Q is either Anand go to school or office. The right side of the panel is disjunction set. The first set is A and the second set is B. The center portion is A union B, that is common in A and B. conditional statement. If P and Q are the statement, then the statement P then Q is called conditional statement, which is read as if P comma then Q. In this statement, P is called antecedent and Q is called consequent. The statement P then Q has the truth value T when both P and Q has the same truth value T comma T and F comma F. Otherwise, it has the truth value second value of the consequent. Truth table for conditional statement. The first column is P, the second column is Q, the third column is P then Q. By the definition of conditional statement, the fourth point is both the value having same truth value, it will come true. Otherwise, the second value of the consequent is true, it will come true. Otherwise, it has the truth value false. Example problem. Construct the truth table for P then Q and Q then P. Solution. First column is P, second column is Q, third column is P then Q, fourth column is Q then P, the fifth column is P then Q and Q then P. The first column of P having the truth value true, true, false, false. The second column of Q having the truth value T, F, T and F. Next, the third column is T then Q. Here we wrote all the statement according to the conditional statement. Again, the fourth column Q then P is also right by the definitions of conditional statement. This is the both truth value same means it will come true, and the second value is true means it will come true, otherwise it has the value false. The fifth column is P then Q and Q then P. Here we want to multiply third and fourth column. True into true, it will come true. False into true, it will come false. True into false, it will come false. True into true, it will come true. Biconditional statement. If P and Q are any two statements, then the statement P if and only if Q is called biconditional statement, which is read as if and only if. That means P if and only if Q. The statement P if and only if Q has the truth value T whenever both P and Q have the same identical values, otherwise the truth value is false. Truth table for biconditional statement. The first column is P, the second column is Q. The first column of P having the truth value true, true, false, false. The second column of Q having the truth value true, false, true, false. The third column is P if and only if Q. By the definitions of biconditional statement, by the third point, the same truth value means it will come true, otherwise it will come false. Example problem. Construct the truth table for negation P and Q if and only if negation P sum negation Q. Solution. The first column is P, second column is Q. After the negation P, negation Q, P and Q, negation of P and Q, negation P, sum negation Q, negation P and Q, if and only if negation P, sum negation Q. The first column of P having the truth value true, true, false, false. The second column of Q having the truth value true, false, true, false. The negation P is true, it will write false, true, it will write false, false, it will write true, false, it will write true. Negation Q is false, true, true, false. P and Q is we want to multiply the first two columns. By the definition of conjunction, both truth values having true means true, otherwise it will come false. Next, negation of P and Q. The first row of P and Q is true, so it will write false. Otherwise, remaining three rows, it will come true, true, true. Next, negation P, sum negation Q. We want to sum third and fourth rows and columns. First is false, sum false. It will come false. False, sum true. It will come true. True, sum false. It will come true. True, sum true. It will come true. The last column is negation of P and Q. If and only if negation P, sum negation Q. By the definition of biconditional statement, both truth values having the same truth value, it will come true, otherwise it will come false. Here, negation of P and Q and negation P, sum negation Q having the same truth values of all rows. So, it will come trues for all rows. Thank you.